Again, I just kind of briefly went over the last video, what you missed, and all these timestamps that are for the videos from the last video that you might have missed. So I'd recommend just popping into here if you haven't done this. Really do it. The stream gets better every week, I'm aware, but also you're going to really benefit from doing these steps, making sure you have Python, VS Code, Homebrew, Git, Mini Conda. I mean, this is how we're going to work through this project for the next couple months. So it's going to be very important to have your environment set up appropriately. Great. That's that. And then, like I said, we'll just get started with Conda. Not installing the latest version of Conda. We're installing 3.10.6 instead of 3.11. I was having some issues with PyArrow, which is a dependency of PyBaseball. So PyBaseball is a really great library that I use to pull down some of this data. I've just gotten started with it recently, so you and I are going to learn together, and it's going to be awesome. Next up, we'll pop into my iPad. So the iPad, I do have some stuff prepared on there just to kind of brainstorm and think about what it is that we're really driving towards. I think that's something very important in data science, and really any work you do is to be sure of what it is that you're working on, why you're doing it, what you're doing. So I got that in the iPad, and then we'll get into the code and data. I know everyone's kind of itching to get in there and also see what my skills are. I know I'm itching to show you, so it'll be fun. It'll be a fun time to learn. It'll be a fun time for you to learn, for me to learn. And everyone's going to go through this together. So anyway, without further ado, let's go ahead and get this show on the road. So like I said, the first part is making sure we have our Conda environment appropriate installed. So you see here I have the file, and remember this was from Cookie Cutter last time. So I'm going to go through and check out I'm going to clear my screen first of all. Okay, and we're going to go through and we're going to check out the different environments I have in Conda, just to see what it is that I'm working with. So Conda deactivate, Conda environment list, Conda env list is going to show you the different environments you have on your computer at the time through Conda specifically. So you see MLB betting and Powerball environment. So Powerball's for a lottery project. MLB betting a lot more likely to pay off than a lottery project, by the way. Next up, we're going to go ahead. MLB betting was something I had already created, so I want to create a new one with you. So I'm going to go ahead and actually make sure I'm in my desktop. So I'm in my desktop. It doesn't matter, but we're going to create a new environment. And like I said, we'll do over under project to make it the same name as the file directory that you all are using. And like I said, we're not going to install the most recent version of Python due to some issues with PyArrow. So we're going to do Python 3.10.6. So you see Conda create Python 3.10.6. That's what we're creating here. So go ahead and get that up. Takes a second. You want to make sure everything solves, everything gets done correctly. Go ahead and proceed. It's just going to install some of those basic packages. Today, I'm streaming off of my laptop screen, not the external monitor. I feel like it'd be easier for a lot of you to follow on the laptop screen versus the external monitor. So get a better resolution for most of you out there. Most of you are going to be watching on laptops or smaller screens than the ultra wide I'm using. Conda activate over under project, remember that. So Conda activate over under project. Great. So we are now in our project again with Conda 3.10 or Python 3.10.6, and we're in the desktop. I'm going to go ahead and change it into the directory that we're working out of. So we're working out of over under project. Now I have both the over under project environment and the over under project folder loaded up. So let's go ahead and pip install PyBaseball. That's all it's called. And all this is going to grab catched because I've downloaded it and I've used it, but I haven't used it in this environment, so it has to go through and do it. So you can pause this video if it takes you longer than me. Makes sense if it takes you longer than me. It's trying. There it goes. All right, so it has successfully installed. I do believe I can get in there. So type Python, import PyBaseball. So this is just to check and see if it has actually installed, and you can import it. If you can import it, most of any problems you'll run into is going to come when you actually get into the importing the package. So we see it imported correctly here. So now we can exit out of Python. Now we're back in our environment. Great. So now we know we have the environment set up. We're in the folder we need to be in, and we have PyBaseball. So let's move on over to the laptop screen so we can talk a little bit about what it is that we're trying to do with this project. So I'm going to throw an example at you. Awesome. So I had to make sure my mic was on this time too. So when you see the screen here, the first thing is, what do we want? What are we trying to do? So let's take an example. So our example is right here. So Philadelphia versus Houston, over under 7.5. I'm using the Philadelphia-Houston example right now because of the World Series, but this is what you want to pay attention to. Philly-Houston, over under 7.5. This is kind of our goal. We want to know, we want to understand, like, what is it? How are we going to be able to do that? How are we going to be able to get 7.5? That's the Vegas line. How can we do this? So we're going to predict how many runs were scored. So we have some data science techniques we can use. So we can use simulation. Simulation is something that you work on a lot in grad school. So I was thinking triangle distribution for team total runs. So if you have a chart that looks like this, this is the low end of that bell curve, the high end of that bell curve, and the low end again of that bell curve. So think about normal what bell curve looks like, except you're using, just describe it with a triangle distribution, and it's going to look something like that. So then you have low, medium, high in your distribution, and you can basically just assign them each like frequencies, like how often they happen, and then we'll create a simulation, and we can simulate total runs in a game for a team. It's a little not granular enough for me, but then the other side of that is simulating each at bat. So if you simulate each at bat, that might be a little too granular. So, and also simulation might not be the right move, right? Maybe it's something else that's going to be best for the situation that we're working within. So traditional machine learning also, so we think of cat boost, we think of XG boost, some model with player performances as input. So that's kind of what we're going to be working with the whole next couple months, is how can we format our data set to be kind when we're thinking about machine learning models. How can we get something appropriate for that scenario? So let's drop down a little bit. So what does that look like? What does that data look like? What are we going to eventually be using? So we think of game on the left hand side in the kind of like that ID. That ID is your game right here. And then on the right hand side, that's your Y's, your runs. That's what we want to know. We want to know about how many runs are being scored in each game, and this is when we go into training our model, right? This is kind of what our data needs to look like. The big question is what goes in here? What goes in the data spot? Because what's going to be able to tell us how many runs are scored? So this is why people don't like building models. There's so much data. It's ambiguous. It's hard to understand where to go and why to go that direction. So I just put some notes down here at the bottom. So we have batter performance, expected on base percentage, expected batting average, wins over replacement, wins above replacement. So that's a couple like batter performance. Also, wins above replacement's a fielding statistic. Then you have pitcher performances. So Sierra is one of the newest kind of calculations for ERA for pitchers. It's ballpark adjusted, home run adjusted, like a lot of adjustments are done in Sierra to really get a sense of the pitcher's true skill. Something I like to use when I'm betting just kind of without a model, but using my mental model, is hard hit percentage. Hard hit percentage, barrel percentage. And what I'll do is I'll grab that pitcher, also pitch choices. So when you think about the top 3 pitchers that this pitcher likes to throw, well, go look at the hard hitters on the other team. So for this example, if you have Houston and Philadelphia, right, you might have Verlander pitching, and then coming up you have Schwarber, you've got Harper, you've got Reese, forget Reese's last name, Hoskins, and these guys, maybe they don't hit the curveball super well, which I don't think they do. I don't think Schwarber or Harper hit a curveball super well. So then you look and you see, does Verlander have a good curveball? No, not really. Okay, well then it kind of is a moot point. Doesn't matter. But if Verlander does have a good curveball, then you have a pitch that pitcher, you assume they're also using the scouting report, can lean on to get this batter out. The problem is when you have a pitcher that has, maybe he only uses fastballs, he only uses changeups, and so these are, fastball with an off-speed pitch, but not much movement on a changeup. And you notice that these guys are hitting fastballs, they're hitting cutters, they're hitting they're hitting changeups, all pretty well. So these hard-thrown pitches that don't have a lot of movement, because if you're some people, your cutter does have a lot of movement, but if you have these straight pitches mostly, and they're just getting knocked, then you have better faith that the batter is going to perform better in that situation than the pitcher. That's how I tend to use it, but we'll see if the model proves me right or wrong. And then also team performances. So like I said, I think maybe last time, I like to do first five a lot more than I like to do full game stuff, because when you do first five, you don't really have to worry about that. When you start thinking about the bullpen and how the bullpen's going to perform, who's coming up, right? Like, so you got to think about who are their top performers in their bullpen. Also, same thing as starting pitching, right? Like pitch count, like pitch choices, Sierra, hard hit percentage. So who's likely to come up is also dependent on rest. So you're not just taking into account the best people in their bullpen, because the best people in their bullpen might not come up, because guess what? They're probably already been used, especially, so we'll talk about runs too. Not runs in a game, but like streaking. When you have a lot of overs, an over will follow an over, because the team has been using their stars in their bullpen. So now all of a sudden the team has to fall back on less quality stars. So you can kind of double up. We're talking about double dipping when you have a weak starting pitcher. You have a bottom of the rotation 4 or 5 guy, and then you have a team that's been on overs the last couple of days. It's something that I really, almost an automatic. So that clues us into recency. There's going to be a lot of recency in over-unders. And then finally, weather. So you think wind speed, whether it's going in or out, could affect likelihood to have home runs in the game. You also think about temperature. If it's really cold, your hands are getting icy, and it's not super hard to hit a ball when your hands are super icy. So these are some of the things about weather that are also important. Can we get into a weather API? Yeah, we can. AccuWeather has an API, but it's going to be a lot of work. So that'll be kind of a plus for our model, but we won't start there. We're definitely going to focus on getting the other data. So I just wanted to run you through that and kind of introduce you to what it is that we're going to be working on, and how we can start to think about this project in a productive way, right? Let's go ahead and move in to the coding part of this. It's going to be awesome. So go ahead and open up VS Code or whatever editor you want to be using. It's also fine. I choose to be using VS Code. And let's go ahead and open up GitHub. We're going to go ahead and hop over to the Pi Baseball GitHub page. So I've included this in the link also. So we're able to come in here and kind of look at Pi Baseball. So here's another way to download it. Also, you can clone in and pip install from the clone, in case the original pip install doesn't work for you. But let's go ahead. We see some examples. Let's go ahead and pull these examples in and just really get an understanding of what's going on. So going to SRC, we're going into dev. Remember, this is my first file that I'm creating in here, so I really want to get an understanding. So we'll name it PyBaseball practice.py. And actually, I won't do .py yet. I will go ahead and use a notebook. I don't love notebooks, but I think they do have their place when we're in an exploratory state, when we're trying to play around, trying to visualize things. I think notebooks are nice. Make sure your notebook is using the right Python environment. So we'll need over/under project, and then it's going to ask us to install kernels because you need the IPy kernel to run Jupyter in VS Code. So you gotta run that piece of code. No problems. Usually runs pretty quick to get to this point, and then you just gotta install the packages. But overall, not a hard process. It just has a lot of dependencies. Nothing that takes super long to install. I hope you all are excited. As excited as I am to get this party started. And a lot of this is getting started. Is being able to get the environment, get everything working correctly. Let's see. Can we import StatCast from PyBaseball? Yes, we can. Sounds good. So I've imported StatCast from PyBaseball. Everything's good. I'm working, no problem so far. All right. So next up is the StatCast. So we're going to go ahead and pull down some StatCast data. This is again from that little example that they showed us. So if we kind of take a look at the example, we'll see StatCast data include pitch level features such as perceived velocity, spin rate, exit velocity, pitch XYZ coordinates. That'll be interesting. In the function StatCast start date, end date pulls this data down from baseballsavant.com. If you're not familiar with baseballsavant.com, that's what I use before I bet on anything. I'm always on baseballsavant.com. So all this data is actually stored up there. PyBaseball, the StatCast, at least function call, makes it really easy for us to be able to pull some of that data down. So we are now pulling, it says it's going to tell us it's a large query, so glad it's telling us that. It's telling us it's going to take a minute to load, and it loaded. Fantastic. So we're looking at pitch type, game date, release speed, release position X, release position Z, all the way over to delta run expected. So this is where my other project will come in handy. And I will show you, I'm going into references, I'm going into data dictionary, and I will paste this in our references file as well, so that way we have it. So I have the data dictionary for this that I've been editing, keeping up with. So we will preview this markdown. So this is what all those columns are. So now in our references page for the data dictionary, we will have the data dictionary now in the references page, very important. And we'll be able to get an idea of what all these pictures are. So we can close this out. We don't need this. We really just need the preview, and we need the data. And you see there's a lot of columns here that are not being displayed. So that means we need to import pandas. PD set options, import pandas as PD, and I forget what it is. Max calls pandas. So trusty Stack Overflow, and it is right here. PD set option. That's what we're looking for. Thank you, Stack Overflow page. Specifically, thank you to Wouter Overmeyer. Nice. And Peter Mortensen. Working together. Teamwork. So, allowing us to get that done, we'll say this is 92 columns, so we'll set it to 100. So it is going to reload that, but it runs a little bit faster the second time because it is going to catch some things. And have them saved in memory, but we also redisplayed all the columns. So first thing I see is that there's a couple of deprecated columns. I really don't want to be using those, so I'll probably try to get rid of those. Game type stand, player throws. Okay. Let's keep making our way down, actually, the tutorial. The README here, see if we find anything else. So this is going to give us a lot of really good information. What about, yeah, so how about this? For a player-specific StatCast query, pull pitching or batting data using the StatCast pitcher or StatCast batter functions. Okay, so the function that we ran is StatCast generally. So it looks like it's telling us the player name, Matt Bush. It applies to him. It looks like the batter changes in each one, and this is the pitcher, so this one must be the pitcher. But it's looking like it's telling us that StatCast batter, StatCast pitcher, it'll give us the play from that character's perspective, from that person's perspective. So these take the same start date and end date arguments as a StatCast function, as well as a player ID argument. This ID argument comes from MLB Advanced Media and can be obtained using player ID lookup function. So we are going to import that and we are going to use it. I don't want to use, I guess Clayton Kershaw is fine. So we're going to generate this player ID lookup table. So we see we have from MLB Advanced Media, he has an ID of 477132. Retro key of Kursic 001. Baseball Reference, Fangraphs, played first, played last. So Baseball Reference, Fangraphs, MLB, this is all really good. It is different keys that we're going to use to be able to reference back specifically to Clayton Kershaw. That'll come in handy later when we need to, especially be building things. So we're going to load up some Kershaw stuff, and we're going to check out his pitching performances. So MLB AM ID is 477132, so we feed that as a player ID argument to the following function. So the StatCast pitcher is going to receive the MLB Advanced Media ID. So that's a good thing to note. If we were to program it like that, right, we might try to build it in this way. So this would be Kershaw row, and then we're going to set that. We're just going to set that equal to this, and then Kershaw row, and we'll do key MLB AM dot values, and that should give us the right value. Yep. So we've got 477. What if I do 0? If I do 0, we can't. There we go. So I did 00 to access the true number instead of giving me an array. So what we can do then, Kershaw key MLB, and that's MLB Advanced Media again, and we can feed that right through here. So you might already be thinking how that's going to be useful to us later, because we don't have to manually type it in each time. And then from PyBaseball import StatCast pitcher. So I really want to also kind of drive through what I just did. So player ID lookup, by looking up Clayton Kershaw, we got this row back, right? Remember that? So we're getting this row back, Kershaw row is just this. So if I access Kershaw row MLB Advanced Media key, which is this one right here, I'm just accessing this value. It's giving me an array because I'm technically pulling that column down, but there's only one row in that column, so it's giving me just a list with one entry pretty much. I had to 00 just because that's what I saw in the output in order to access the value by itself. So now Kershaw key MLB AM is just equal to that number. So if it's just equal to that number, we can feed it right through the StatCast pitcher, and it should give us Kershaw's performance. All good. We do get 2 at-bats because we pulled head 2. We do get 2 at-bats from Kershaw, which is really nice to be, it's really nice to see that we're getting what we should be getting or what we'd expect to be getting. Make sure we're at time, so we're at 30 minutes. Okay, great. So pitch type slider. See game date 2017 6/29. So June 29th, 2017. Release speed on the slider. Release position X and Z on the slider. So that is going to be interesting. I mean, does consistency of release speed or release position matter? Can we look for big standard deviations? Like maybe last game his release position is off a lot, and so now we have less confidence, right? Like off compared to normal, so showing a larger standard deviation from the last game. So who knows? Maybe it's important. Clayton Kershaw, we know that's who we searched, so that's nice. It can kind of confirm that, validate it for us. We have the batter, and then we have the pitcher. Remember, 477-132, 477-132, 477-132. So the pitcher column is going to give us that MLB Advanced Media number. The batter column gives us the MLB Advanced Media number for the batter. And this batter specifically is Eric Young Jr., who struck out. We know he struck out because we see events. We see events, strikeout, description, swinging, strike, blocked. So each pitch will have a description, but not each pitch will have an event. So each pitch will have something happens, right? So swinging, strike, blocked means it was in the dirt, he swung, blocked it, struck out. The one before that, it was a ball, but nothing happened, right? The at-bat continued. So that's kind of what we're seeing there. Spin direction, spin rate deprecated. We'll get rid of those. Zone, so we can come in here. Zone location of the ball when it crosses the plate from the catcher's perspective. So we'd have to see if we can find zone's probably a good variable, because if we can say he swung, and then we can say it was out of the strike zone, right? So zone 13, since it was a swinging strike blocked, we know that it was in the dirt. So zone 13 is in the dirt. So we can get maybe a chase. Maybe we could give him points for batters chasing his pitches. But you don't want to give too many points for batters chasing, because that means they're throwing it out of the strike zone too much. And essentially you want your people to be throwing it in the strike zone. Game type. So let's see what game type would be. It is a regular season. R is going to be for regular season. Stand, batter stands right-handed, pitcher throws left-handed. Home team, Angels. Away team, the Dodgers. Type, ball, strike. So type is the type of pitch, whether it's a ball or a strike. What else is it? In play. So X would be an in-play ball. Hit location, 2. So let's see what hit location is. Position of the first fielder to touch the ball. The catcher. So the catcher is the first position to touch the ball. Anyway, so that's how we can kind of interpret this data. I don't want to go all through it right now. I kind of want to keep working through the GitHub. So really good information in these things. You got to take the time to go through them. So note on StatCast data, it's subject to change even for the prior season. Each season has 700,000 plus pitches and subject to updates. You should code accordingly. So it's a great reminder. Handling breaks in your code. Sorry, I thought my mic was muted again. That was not going to be great. So we need to be able to handle breaks, which is going to be into exception writing. So that's going to be a really good point for later. So pitching stats for players across multiple seasons, single seasons, or during a specified time period. So this library contains 2 main functions for obtaining pitching data per league-wide season. So what this next section is going to allow us to do is just grab a pitcher's performance over a certain time. So that's why we have pitching stats. And we can grab, like if we want to grab from April till now. So you want to grab this season, we can grab this season. And again, we have a bunch of other columns that we'll be able to use in this data. If you prefer baseball reference to Fangraphs, so it looks like this is using Fangraphs, this call is, and there's a third call which allows you to use baseball reference, and it works the same, except it only allows you to call 1 season worth of data per request, which is going to be annoying, so we're going to use the Fangraphs. And then batting stats as well, so we have the same kind of information for batting. Good information like stolen bases caught stealing. So you'd think if you have a lot of stolen bases on your team, more likely to score runs, batting average, on-base percentage, slugging percentage, OPS, all really good information. Game-by-game results and schedule. So we could look for, if we see we have runs and runs against, so we do have the total runs, we can compare these total runs against those lines, so that gets into pulling those odds, and we'd be able to look at that. So standings, updated historical. So this is all really good information. The head-to-head statistics, standings, updated historical, division standings, win-loss records might be important to facilitate faster data retrieval for repeated calls. A local data catch might be used. So it looks like you can enable the catch in Pi Baseball, which is good. We'll probably do that. And if you're getting error concurrent futures process, broken process pool. So we're not getting an error, so it's fine. So we'll be fine for now. And complete documentation is in the docs folder. So it's a very, very basic README, just fine. There's a lot of stuff, and all of their more in-depth stuff is going to be in here. So anytime you see something end in MD, it's a markdown file, so it's probably going to allow us to look at how this function works. So this is also going to be for all the different functions that they provide us. So pitching stats. So we can get pitching stats for players in a season. So you have start season, end season. You can do multiple seasons too. League. So all for both leagues. AL for American, NL for National. Defaults to all. Qualification, so minimum number of plate appearances to be included in the results, defaults to none, which is equivalent to the current Fangraphs qualified plate amount threshold for their leaderboard. So Fangraphs apparently does not require a minimum plate appearance threshold from their leaderboard, so that's really interesting. Indicator 1 equals 1 if you want data return at an individual season level, equals 0 if you want aggregate data over the seasons included in the query. Interesting. That could be very useful. Could be very useful to have the difference between per year and also aggregating the year, so we don't have to do that ourselves. And this is just some of why it's good to get an idea of what documentation you have. I'm not going to go through everything, but I am going to look at some things. So here we have team batting. Looks like we have some of the same stuff in team batting. I want to get a better idea of StatCast, because StatCast is dense. Good, it looks like they have some good stuff in here. So we can look through, we can get, so Chris Sale is what they're getting here right now. They're getting his MLB album, MLB ID key. They're keying that in, and they're getting some information on him. So exit velocity barrels. This function retrieves batted ball against data for all qualified pitchers in a given year. I want to run this right now just to see what kind of data we get back. Batted ball barrels. Exit velocity barrels, not batted ball barrels. Cannot import name. That's interesting. So that's another thing. Not everything might be working. Let's try this next one. Yeah, that's not great. Unless it's me. But I would not be able to believe that it's me all the time. I mean, I would assume one of these would work. From Pi Baseball. If they had this part wrong from Python, who's to say they didn't have other things wrong? Yeah, so it'd be worth it. And it looks like it hasn't been updated since March 13th, 2021. Let's check the history on this. Let there be partial documentation. Make readmes look nice. See, 2017 is the first commit. So I can't really trust, and since the last one was over a year and a half ago, I can't really trust that this is something that is working. Looks like they haven't said anything about it. I wonder if there's an issue open on it. I don't see. So there's a lot of issues I'm seeing with this. And we can get into web scraping too. So we have time. So something we can work on. But Pi Baseball is one of those things that I would like to be able to use. Let's try. Yeah, so I'm not getting luck with any of these. It's fine. We will move on. Let's do StatCast batting, since that was pitching. Let's see if we're getting some of the same issues when it comes to StatCast batting. We are indeed getting the same issues. You just make sure that... Yeah, so StatCast pitcher is working. Alright, so let's pop in. Let's pop into Pi Baseball here. Let's see what we got. So, I'm going to change directories. We're going to go all the way into Pi Baseball. We're going to do open period. So these are the different things that we have to be able to import. These are the different Pi files we have to be able to import. This is what we can look at. That's why we see player ID is working, StatCast fielding, pitcher. So let's do this. Pitcher spin. So let's go back in here. StatCast pitcher underscore spin. See, that worked. So we're able to use this, the location of it. What is in the utils? That makes sense. Just describing some of the valid dates. Most recent season. Date range. StatCast date range. Sanitized date range. A lot, I mean, yeah, a lot of having to work with dates. Interesting that they've already imputed the data for pop-ups, fly balls, line drives, ground balls. See some merging. It's actually really easy to read code, other than the lack of, I guess, documentation on some of these. Not clear on their inputs, what the function's expected to do, and their returns, and then where that plays in. So this utils file is kind of messy, but that's okay. It's really good that this even exists in the first place. So we'll do StatCast pitcher. We'll see what StatCast pitcher has. See, this one has arguments. StatCast pitcher exit velocity. Oh. Well, see, that's why the documentation's wrong for how you pull these things in. Let's pop in. Let's pop into VS Code. All right, we got it. So I moved it over. It was here the whole time. So we see it's called StatCast pitcher, and then this is StatCast pitcher. So we need to import StatCast pitcher as SP. We'll call it StatCast pitcher, right? And then SP dot, and then what's available with SP dot? Well, it should be like this: StatCast pitcher exit velocity barrel. It's really bad to have the same name. Because that's what's going on. It's getting hard. It's hard to Statcast picture info. So then sp dot. Let's see what's available with our sp dot. Not many things. See, because that's why all these are here, but they're just not working. Also, we could essentially, we can pull all of this like ourselves. So if we don't end up finding a good way to make this work, and by we, I mean me, end up finding a good way to make this work, then it's something that we can pull. You see, they're essentially just doing requests from Baseball Savant website. So that's even something we can do ourselves. Yep, and that makes sense why it's not importing. That'll import, but then statcast pitcher exit velo barrels. I shouldn't get so hung up on this, but it is really fascinating that it's wrong. What are we at? We're 46 minutes. We're doing okay on time. We have some time left. I'll give it like 10 more minutes of us just like clicking around trying to figure out what's going on. Because it would be nice to be able to use all these things without having to so let's see. Statcast pitcher exit velo barrels. See, I'm struggling. These things are here to be used. So it's still calling the function, because we would need to kill our kernel, I think, and start over. Let's try that. Let's try restarting our kernel and see what happens. What is it going to call now? Cannot import name statcast pitcher from PyBaseball statcast pitcher. Well, will it call? It won't call that. I wonder why it won't. That's okay. I will accept it and move on for now, but I will come back with you next week and we will figure out how I will kind of take you through next week on what I did to get around it. I will find a way to get around this. It's just kind of figuring out how. So yeah, fascinating. Let's go ahead and go back to their documentation. Be a very useful process for us. So a lot of these things we can't get to work, and that's okay. And actually we've gone through most of the documentation. All right, I have a use case pulled up that I would like to walk through. I'm gonna go ahead and pull up my other sports betting project, SRC dev. This is the one, yes sir. Okay, so something that I want to get a look at is, well, I specifically started looking at John Lester. But also, like I said, remember that we have deprecated columns and we want to get rid of those. Actually copied and pasted my code, but I won't do it. So Kershaw stats, let's go ahead and use what we've been using. Columns. Kershaw stats is not defined. It's because I can't write. Oh, it's because I haven't actually called it in yet because I restarted my kernel. Oh no. Oh, I messed it up. All right, we are going to, guess what we are going to do? Pip uninstall PyBaseball. So yes, I would like to continue PyBaseball. See y'all, not perfect, we're here to learn together. What are you executing? Pip from can no longer be found. Oh yeah. Hit. Where am I? Oh my goodness. All right, finally back on the desktop. All right, and then I'm going to pip install PyBaseball. We're gonna reinstall it. We're gonna shut down the kernel. All right, I'm gonna try to run it again. All right, fixed it. Sometimes this happens. Now we're running everything again. We're gonna pull all that data back in. Not all that data. I don't recommend pulling in large chunks of data at once. It's kind of unnecessary. Not something you need to go through. Torture your computer by holding large amounts of data at one time that you're not really doing anything with. Cool, all of our data ran again. But let's pull out this one, right? A specific example. This TFS Zulu deprecated. So I don't know what it is, and I don't need to know what it is because it's deprecated. So we're going to go ahead and get rid of all the columns in the data set that are deprecated. So this is our first kind of exercise here. Let us do some, and I have it already. I'll just use it. So regular expression. So the first thing we want to do is compile the regular expression. We need, actually the first thing we need to do is import RE since we're using regular expression. And what we're searching for is period star, which is any amount of characters before, any amount of characters after, but the name deprecated appears. And then we're going to go ahead and search Kershaw stats. So we're going to do column for column in Kershaw stats.columns. So this runs in ON time, but they're column lists, never going to really be that big. If not, matching the pattern. So keep that column if it doesn't match this pattern, which is exactly what we want, because we want to make sure that we get the non-deprecated columns. Now, we want to filter so that way we're only keeping the non-deprecated columns. So Kershaw stats. Kershaw stats equals Kershaw stats non-deprecated. So we're doing kind of like a Boolean matching type of thing because each column is going to get like a true false kind of deal. Or actually, no, I don't think non-deprecated is going to come up with the true false. It's not going to be a Boolean. Let's check that. Let's check that to be sure what it is that I'm working with. Oh yeah, let's import regular expression, non-deprecated. Okay, just gives us the list of columns, not the boolean. Gives us the list of columns that it wants to keep. So that's why you're just filtering it like this. You're just saying, hey, only include these columns. And now we have fewer columns than here, which is great. So I'm going to go ahead and delete this since I don't want it anymore. Delete that since I don't want it anymore. And again, here's my top 4 of Kershaw, and you see, like earlier we saw next to spin direction there were some deprecated columns. Now we don't see them. Kind of in this area there were some. And also we can check the shape. So we can do Kershaw stats dot shape 1. That's the number of columns. So we have 87 columns. Remember earlier we had 98. So we got rid of 11 columns. By getting rid of the deprecated columns, which is good because we're already working with 87 columns. So that's a lot to work with. So we don't want to work with that many columns. Check on my stream. Everything seems to be going well. Okay, good. Looks like my screen got stuck. My screen's stuck on your end? Yes, it does appear that my screen is stuck on your end. I wonder why that is happening. Let's go away from it, come back. That's interesting. We're going to take it off and throw it back on. Just to make sure that was it. All right, we're back. We're back with the display. Sorry about that. Anyway, so we loaded RE, we loaded regular expression, we loaded our data in, we loaded up Clayton Kershaw, remember that key, MLB advanced media. Then we have the row, and we end up pulling his values, right? So we were looking at this data, and then we see these deprecated columns. So what we did is we wrote a regular expression to get rid of that. So the pattern, RE compile, deprecated, yes or no, and then you just choose the ones, so it matches the pattern, and then you want to choose the column, so column for column, in the columns of that data set that don't match that pattern. So you specifically do not want to match that pattern in the columns that you keep because we're searching for deprecated columns. So if not in that pattern, great. So now get the list of column names, filter them down, look at those columns. So we can put that here. That's the head of that data set. We can also look at that columns. So you have 2 different ways. You can look at the length of this. And you can see, oh, there's 87. You can also Kershaw stats dot shape 1, and that'll tell you 87 again. And that's just how many columns you have in the data set. Remember that was different than our 98 that we started with, so we have less. Okay, I'm at an hour. I'm gonna go ahead and cut this off. Sorry, there was a little bit of technical difficulties throughout the way, but remember we got into the data, we got into the documentation, we started working. So one of the things I'd really recommend over the next week is to really just start playing around with this, start practicing, try to get a little more comfortable, try to get your hands on the data. We'll move faster next week for sure. We'll try to get more accomplished, but now we have a general idea of what it is that we're trying to do. We have a better idea of what that data looks like, at least for the pitching StatCast. So I'm going to come at you with some brainstormed ideas next week about what it is that we can do with this data. And we'll start working instead of trying to play around with Pi Baseball and figure out why it wasn't pulling the modules in correctly. But I will work with that over the weekend, at least over the rest of this week at some point, and as well as over the weekend I will work with that to make sure we're at a spot where we feel good when we're working here next week, that we can pull all those functions as expected. Thank you very much for coming this week. thank you very much for tuning into my stream. I really do appreciate the time you take to hang out with me from my room, good old Raleigh, North Carolina. If you liked it, give it a like. If you liked it, give it a subscribe. Really would appreciate it. And we'll be here again next week, 7 p.m. Eastern, working on this same project, the MLB betting project. Excited to see you there.